So here you have the definition of inverse of a function. If a function f from set x to y such that fx is equal to y is 1, 1 and onto function. See, the function has to be 1, 1 and onto. This is the most important part of the definition. If it is not 1, 1 and onto, the inverse will not exist. Then there exists a unique function g from set y to x defined by gy is equal to x. X will belong to capital X, set x, and y is equal to fx, where y belongs to set y. And g is called the inverse of f, which is denoted by f to the power minus 1.
This is the graph of y is equal to sine x. So y is equal to sine x. You can see it moves like a wave. So it is many one function. And a many one function cannot have an inverse. Inverse will only exist if the function is 1, 1 onto, that is bijective. How can I make this many one function, 1, 1 function? It can be done by restricting the domain. From minus pi by 2, this is minus pi by 2. If I restrict the domain from here to here, if only this part of the graph is there, this is an increasing function. What kind of function? It is increasing function. 1, 1 function, 1, 1 onto function is always an increasing function or decreasing function. This is increasing function. Therefore, if I restrict the domain from minus pi by 2 to pi by 2, this y is equal to sine x becomes 1, 1 onto function. Now, we can take other branch also. If I take from pi by 2 to 3 pi by 2, still in this case it will be decreasing function. Again I can take from 3 pi by 2 to 5 pi by 2, and so on. I can take many branches, but this is the principal value branch. We are concerned with only this part. You will find here the x-axis represents the angle and the y-axis represents the value. This is the domain, this is the domain, and this is the range. That is, we are going from angle to value. If x is equal to pi by 6, the value is 1 by 2. So from angle to value, but in y is equal to inverse, y is equal to sine inverse function. Here the domain becomes the value. Here value was the range. Here value becomes the domain. And here angle was domain. Here angle becomes the range. Just the reverse. And if this part of the graph I plot here, x is equal to sine y, that is, if I take y is equal to pi by 6, then what is x? It is sine pi by 6, 1 by 2. So pi by 6, 1 by 2. Value, I go from sine inverse 1 by 2 is equal to pi by 6. From value to angle. From value to angle. And this is the graph of y is equal to sine inverse function. Here the domain is minus 1 to 1, but the range, it is minus pi by 2 to pi by 2. This is called the principal value branch. Principal value branch.
So you can see on the left hand side the graph of y is equal to sine x, and on the right hand side graph of y is equal to sine inverse x. You can obtain the graph of sine inverse x from y is equal to sine x by interchanging the x-axis and the y-axis. on the left hand side, that is in the graph y is equal to sine x axis represents the angle and y axis represents the value. Whereas in the graph y is equal to sine inverse x on the right hand side, the x axis represents the value and the y axis represents the angle. So since sine 0 is equal to sine pi is equal to 0, the sine function is not a 1-1 function. Therefore, if I restrict the domain in a closed interval from minus pi by 2 to pi by 2, then the range is minus 1, 1. And the sine function is a bijection, as I have shown you. And sine inverse will exist if the domain is in a closed interval from minus pi by 2 to pi by 2. Therefore, by restricting the domain, we can make it 1-1 onto function. Now, the domain of sine, few of the domains are given, although there are many, but amongst the three that is given here, in a closed interval minus pi by 2, pi by 2 is the principal domain. Therefore, for sine inverse, the domain of sine inverse is in a closed interval minus 1, 1. The range of sine inverse in a closed interval minus pi by 2, pi by 2. The principal value branch of sine inverse is in a closed interval minus pi by 2, pi by 2. This is very important. And you know, if y is equal to sine inverse x, sine y is equal to x.
So in this question, we have to find the principal value of sine inverse 1 by 2 and sine inverse minus 1 by 2. Now deliberately I have taken one positive and one negative value. Now for this, we need to know that the domain for y is equal to sine inverse x is a closed interval from minus 1 to 1, and the range is closed interval from minus pi by 2 to pi by 2. Now minus pi by 2 to pi by 2, it's the first quadrant and the fourth quadrant. In first quadrant we write theta, in the fourth quadrant we write minus theta, and theta is between 0 to pi by 2. Now, how to solve the problem? Right here, let x be equal to sine inverse 1 by 2. So what we get from here? That is sine x is equal to 1 by 2. And here we should know that x is less than and equal to pi by 2 and greater than and equal to minus pi by 2 is the range. So sine x is equal to 1 by 2, and this is sine pi by 6 is 1 by 2. Therefore, what is the value of x? X is pi by 6. So we write sine inverse 1 by 2 is pi by 6. This is the answer. This is for the positive number. Now I take for the negative number. And here x is, which we have to write, the range. This is minus sine pi by 6. But this is negative. Negative means sine is negative in the fourth quadrant. So we write here sine x is equal to sine minus pi by 6. So we have x is equal to minus pi by 6. And therefore, the final answer, sine inverse minus 1 by 2 is equal to minus pi by 6. So the quadrant is important. If it's negative, fourth quadrant minus theta, and if it's positive, the previous case I had taken, it is plus theta. So this is the graph of y is equal to cos x. Just like sin x, This is also like a wave, and it is many one function. And many one function cannot have an inverse. So to convert this to one onto function, we have to restrict the domain. We have to restrict the domain from 0 to pi, 0. This portion to this portion. You'll find this portion, the graph is decreasing function. And this is 1 onto, we can also say bijective function. The range is from -1 to 1. Now, this value from 0 to pi is called the principal value. But this can also be -pi to 0 or pi to 2 pi and so on. But we take this as the principal value. Now the inverse, you'll find here the domain is the angle. And this is the graph of y is equal to cos inverse x. Here domain is the value. Inverse function, domain is the angle. Here domain is the value. And here the range is the value. Here domain is the value. And here range is the angle. So this is the graph of y is equal to cos inverse function. If cos y is equal to x, y should be in a closed interval 0 to pi, from 0 to pi, less than or equal to pi and greater equal to 0. And this is called the principal value branch. 0 to pi. Other intervals are these, but amongst.
So this is the graph of cosine function and cos inverse function. You'll find on the left hand side the cosine function. It is many to one function, but if you restrict the domain from 0 to pi or pi to 2 pi or 0 to minus pi or minus pi to minus 2 pi, it becomes 1 onto function. And if you interchange the x and y axis, you can obtain the cos inverse function. The x-axis of cosine function represents the angle and the y-axis represents the value, whereas the x-axis of cos inverse function represents the value and the y-axis represents the angle. Likewise, cos 0 and cos 2 pi, the value is 1, and therefore the cosine function is not a 1 function. But if I restrict the domain in a closed interval from 0 to pi, the range is -1, 1, closed interval. And then the cos function is a bijection, that is 1 onto function. And then the cos inverse will exist. I have explained you this. Therefore, when the domain of cosine is restricted from -pi to 0 in a closed interval, 0 to pi in a closed interval, and pi to 2 pi in a closed interval, and many more, the range is -1, 1 in a closed interval. Therefore, the inverse of cosine exists if the domain of cos inverse is in a closed interval from -1, 1. The range of cos inverse is in a closed interval from 0 to pi. And remember, the principal value branch of cos inverse is from 0 to pi, closed interval. Similarly, you'll find the graph of tan x and tan inverse function. On the left hand side, y is equal to tan x. On the right hand side, y is equal to tan inverse x in the same way. Here, y is equal to tan x, the domain is restricted from -pi/2 to pi/2. It is not inclusive. Similarly, pi/2 to 3pi/2 and so on. The principal value branch for tan inverse is in an open interval -pi/2, pi/2. So here you have graph of y is equal to cot x and y is equal to cot inverse x function. To make it 1 onto function, you'll find The domain is restricted from minus pi to 0, 0 to pi, and pi to 2 pi. The domain of cot inverse is set of real numbers. The range of cot inverse is in an open interval 0 to pi, and the principal value branch for cot inverse is in an open interval 0 to pi. This is important, the principal value branch. You have to remember that. So here you have a graph of y is equal to sec x and y is equal to sec inverse x function. For sec inverse function, the domain and the range is given here. The principal value branch for sec inverse is closed interval 0, pi excluding pi by 2. And here you have a graph of y is equal to cosec x and y is equal to cosec inverse x function. For cosec inverse function, the domain and the range is given here. The principal value branch of cosec inverse is closed interval minus pi by 2, pi by 2 excluding 0.
So sec inverse is from 0 to pi, first quadrant and second quadrant. So negative means pi minus theta. The theta is 0 to pi by 2. So I write here sec x is equal to minus 2 by root 3. Then sec x is equal to minus sec sec 30. It is negative, therefore I will write here sec pi minus pi by 6. And therefore we get x as one more step. X is equal to 5 pi by 6. Or we can write the principal value this is the answer. Then what is its value? Let x be this. The question, let x be this. Where x lies between minus pi by 2 to pi by 2 in a closed interval. So I will write here sine x is equal to sine 5 pi by 3. Now sine inverse should lie positive here, negative here. If positive, then here, negative, then minus theta. So first I'll simplify this. I will write here 2 pi minus pi by 3. This is sine pi by 3, negative. In fourth quadrant it is negative. So since it lies in the fourth quadrant, I can write this way. So sine x is equal to so what is x equal to? Minus pi by 3. This is the value of cos x and sin x. Now if tan inverse 3 by 4 is x, tan x is 3 by 4. And inverse function, this is the principal value branch. That is, if it is positive, it is 0 to pi by 2, and if it is negative, it is 0 to minus pi by 2. This is positive, therefore it lies in the first quadrant. So cos x will be positive and sin x will also be positive. So sec x is 1 plus tan square x, 1 plus 9 by 16. I get plus minus 5 by 4. But since it is positive, I remove the negative sign. So cos x is equal to 4 by 5. What is sin x now? Sin x is 1 minus cos square x. Since it is positive, I take sin x as 3 by 5. Answer. I have to find again sin x and cos x. So here, for cot inverse x, it is from 0 to pi. That is 0 to pi by 2, positive, and pi by 2 to pi, negative. This is negative. Therefore, in second quadrant, sin x is positive and cos x is negative. So, cosec x is 1 plus cot square x. I get here 1 plus 1 by 49 or root of 50 by 49, and I get here 5 root 2 by 7. Now cosec, second quadrant is positive. Sine in the second quadrant is positive. So I take plus. So what is sin x? Sin x is 7 by 5 root 2. Now, next is cos x. 1 minus sin square x. (49 by 50). It is 1 by 50 or 1 by 5 root 2. Now cos x in the second quadrant is negative. So what I do? I remove plus sign. Answer is minus 1 by 5 root 2. This is the answer. I take this as y. This is x. So x is equal to sine inverse minus root 3 by 2. We know for inverse function, x should be less than or equal to pi by 2 and get equal to minus pi by 2. Now this is negative. Negative means minus theta. This quadrant. So I'll write here sin x is equal to minus root 3 by 2. Sin x is equal to minus sine pi by 3. I can write here minus pi by 3 sin x. So x is equal to minus pi by 3. So I'll go back to the question. In the question it is given y is equal to sin pi by 6 minus minus pi by 3 I have calculated here. This is sine plus pi by 3. Therefore, answer is